Welcome back to educator.com. This lesson is about integers and absolute value. In this lesson, we're going to find the absolute value of integers. Integers can be used to represent many different situations, such as temperatures and elevations. The vocabulary for this lesson is opposites, integers, and absolute value. Opposites are numbers that are the same distance from 0 on a number line. So, for example, positive 2 and negative 2 would be considered opposites because they're both 2 units away from 0. Integers are any positive or negative whole numbers, including 0. Examples of integers would be negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on. Absolute value measures the distance a number is away from 0. For example, on a number line, the absolute value of 3 is 1, 2, 3 units away from 0. The absolute value of negative 3 is also 3. Negative 3 is also 3 units away from 0. Notice that distance is always represented as a positive number. The number line is useful for understanding positive and negative numbers, and also later can be used to add integers or subtract integers. Let's try an example of finding absolute value using the number line. So 1, 2, 3, 4, 5, 6, 7, 8. We'll put in an extra one, 9. So we need to extend this in the negative direction also. Negative 1, negative 2, negative 3. Let me erase that. Negative 4, negative 5, negative 6, negative 7. Oops, need to make the line a little longer. And negative 8. So we're looking at the absolute value of negative 8. Let's focus in on negative 8. Now we want to find out how many units negative 8 is away from 0. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. So the absolute value of negative 8 is 8. Notice that the answer is positive. The absolute value of 5. 5 is 5 units away from 0, so the absolute value of 5 is 5. The absolute value of negative 2. Negative 2 is also, even though it's a negative number, we're still counting the units away from 0. So the absolute value of negative 2 is 2. Let's look at how absolute value is useful for comparing integers. Here we have some boiling points of elements at sea level. In order to compare the integers, let's first take out the positive value. The positive value is obviously the largest value. The absolute value of negative 29 is 29. The absolute value of negative 452 is 452. The absolute value of negative 411 is 411. The absolute value of negative 320 is 320. The absolute value of negative 297 is positive 297. And lastly, the absolute value of negative 97 is 97. Now, without thinking about the negatives as listed in the problem here, we can concentrate on the values. So the largest value would be 452. 452 is the number that is the farthest away from 0. So if we were to consider these elements, helium, with the largest absolute value, is our smallest number. Let's look at some more examples of comparing integers. Negative 12 and 10. Well, this one's pretty straightforward. Anytime you have a negative number and a positive number, the positive number is going to be larger. In this case, we need to do a little bit of simplifying. The absolute value of 26 is 26, and the absolute value of negative 26 is 26. So in comparing these values, we find that they are equal. The absolute value of 42 is 42, and the absolute value of negative 93 is 93. So in this case, the absolute value of negative 93 is in fact larger than the absolute value of 42. Here's another comparing integer example. The lowest recorded temperature in Asia is negative 90 degrees Fahrenheit. In North America, it is negative 81 degrees Fahrenheit. Which continent has the lower recorded temperature? Let's look at Asia. The absolute value of negative 90, the 90 degrees Fahrenheit, is 90. So to reach 0, we would have to move 90 degrees up. In North America, the lowest recorded temperature is negative 81 degrees. To move up the thermometer to 0, we would have to move 81 degrees. So the lower temperature would be Asia. So the continent Asia has the lowest recorded temperature. At negative 9 degrees Fahrenheit. Here are some extra examples. Simplify absolute value of 8 plus m for m equals negative 29. In this case, we're going to simplify inside of the absolute value symbols first. You're treating them as if they were parentheses. I'm going to do substitution, 8 plus negative 29. I'm putting the negative 29 in place of the m. Let's simplify these symbols. A positive times a negative becomes a negative. So 8 minus 29. 8 minus 29 would be negative 21. And the absolute value of negative 21 is 21. In this example, you're also treating the absolute value symbol as if they were parentheses. Notice that the 5 is directly touching the absolute value symbol. This indicates multiplication. First, let's simplify the absolute value of negative 4 would be positive 4. And 5 times 4 is 20. We have several more operations here, and we're going to treat the absolute value symbol once again as parentheses. First, let's do our substitution. 112 divided by, in place of r, I'm going to put the value 4, times negative 7 plus 45. Let's work inside the absolute value symbol first. 4 times negative 7 is negative 28. Keep writing all the parts of the expression that you have not yet evaluated. Next, the absolute value of negative 28 is positive 28. Oops. Let me rewrite that. $112 divided by 28 is 4, and 4 plus 45 is 49. In this example, we're also using the absolute value symbol as though they were parentheses to first start simplifying. I'm going to substitute the value negative 9 for t. And let's work inside the absolute value symbols. Negative 9 divided by negative 3 is a positive 3. And the absolute value of positive 3 is 3. Lastly, 28 plus 3 is 31. Thank you for watching educator.com.